OK, sweet. Cool. So I'm Victor. And today I want to give you an advanced talk showing different patterns and techniques we can use to build applications with NgRx. And I used to be at Google, where I worked on a lot of key components of Angular. And I used to blog at savkin.com, where you can still go and check out a lot of good Angular content. And some time ago, Jeff Cross, who was also on the Angular team, and I left Google to start our company called Narwhal, where we help large teams build ambitious projects with Angular. And these days, I blog at blog.narwhal.io. Check it out as well. So check out our site to see what we do and how we work. Check out our blog and our Twitter to find a lot of free, high-quality Angular content. Also, we have these 3 books we wrote about the framework, one on the framework itself, another one on the router, and the last one on upgrading AngularJS 1 apps to Angular. So check them out as well. So today I'm going to cover the following. Yes, I will start with a short overview of NgRx and why we should use it and what challenges we will face if we start using it. So the target audience for this talk is someone who is at least a little bit familiar with the ideas behind NgRx or Redux or any state management system that works in this way. So it won't be an in-depth explanation. I'll just give you an overview so you sort of have a starting point. Then I will switch and I'll talk about actions, which is the core primitive that we use when we build applications using NgRx. In particular, I will talk about the 3 categories of actions we often see when we write NgRx applications. Then I will cover the store, which is the most interesting bit of writing your applications with NgRx and Angular. And I will talk about how we decide how we process actions, how to transform actions, how we compose all these building blocks together to implement our applications. So a big part of this talk is based on this wonderful book. The title is very scary, Enterprise Integration Patterns. But this is the best book on messaging I know of. It's a wonderful book. And at least a half or like a third of it applies to front end and to NgRx and to building Angular applications with NgRx. So I highly recommend you to check this book out. OK, so what is NgRx and why we should use it? So programming with NgRx, it's essentially programming with messages. So instead of updating the state in place, what we do is or components rather, they send messages, or they're called actions in NgRx, to express some intent, their intent. And the life cycle of an action looks like this. So we start with the component, the sender, start with creating an action and filling it with data. Okay? Then the component dispatches an action, which essentially adds it to the store. Then the action can be received and processed. And it can be processed in 2 different ways. The first one, the simplest one, is that it can be processed by a reducer. And a reducer is a synchronous function taking the current state of your application, or a subset of the state of your application, and taking some sort of action and creating a new state out of the current state and the action. Basically, it applies that action to the state. So we see an example of a reducer on this slide, which takes a list of to-dos, and it handles one action, which is the add to-do action. So it takes that action, and if it happens, it creates a new list of to-dos with a new to-do added. Okay? And then it returns that list. If we receive a different action, we are going to return the default state, the one from the previous invocation. So that's the easiest way or the simplest way to process actions. The other one is that the actions can be processed by effects classes. And the effects class takes the actions object, which is essentially an observable of all actions flowing through your application. Okay? So everything that happens of value in your application will go through that observable. So the effects class taps into it, so it can take a subset of that observable, and it basically executes necessary side effects to make sure your application works. So often, in reality, many interactions require us to have both an effects class and a reducer to execute those interactions. Here, for example, we see a very simple example when we receive a to-do, and the first thing we are doing in that effects class is that we are posting that to-do. So we are saving it on the backend. And once that to-do is saved, what we're doing is we are dispatching a new action called to-do edit with a payload, and then our reducer will get to-do edit and will modify the local state. So we have a single interaction, which is we are going to add a to-do to the list of to-dos, and it involves having 2 actions. once the first action goes to the backend, the second one updates the local state. So once we're done with this, once we update the local state, what we want to do is we want to often sort of reflect the state change in the component itself, in the template. So that's what we're doing here. In the constructor, we are selecting the state of to-dos, all the to-dos from the store. So we get this observable. And anytime we add a to-do, remove a to-do, or update an existing to-do, that observable will emit a new value, a new list of to-dos, and that list will be displayed by this component. Okay, so graphically, it looks like this. Okay, that's what I told you. Essentially, it looks like this. The component dispatches an action, which goes to the store. And then in the store, it's processed by effects classes, which often involves deciding on how to process an action and transform in an action. Then we execute all the necessary side effects. And finally, the reducer will create a new state, which the component will receive. Okay? That's in a nutshell how NgRx works. And if you don't use NgRx, I recommend to check it out. Now let's look at every part of this picture, at this diagram, in greater detail. Okay? The first part is action. So an action is what we dispatch when we want to express our intent. Essentially, it's a message. Okay? It's a synonym for message. And in NgRx, the action has two parts. The first one is the type, and the type is just a string that you can assign to an action. And the second part is the payload. Payload is some extra information we need to be able to process this action. As with most messaging systems, and NgRx is a messaging system, actions are reified. In other words, they are represented as concrete objects we can pass around and store. And a lot of good stuff that NgRx brings comes from this property that they are reified. Okay? So NgRx is a very simple library, and as you can see, it doesn't actually make a lot of assumptions about what your actions are and what they contain. It doesn't really care how you define those types. You know, it needs to be a string, that's it. It doesn't care how you define those payloads. Okay? So NgRx does not care. It doesn't care how we construct those actions. Okay? So I tend to do it in place like this, just in the component itself. But you know, if you feel like it, you can extract the construction of an action into a sort of factory function. Okay? And it's useful when you want to sort of enforce that certain invariants hold. So if you want to guarantee that, factory function is a good way to do it. So NgRx doesn't impose sort of any constraints on our actions apart from that we should have these two fields. But if you start using NgRx, you know, after maybe a few days, you'll find out that not all actions are alike. There are certain categories that actions fall into. There are actually 3 categories. So actions can be sort of roughly divided into these 3 categories. The first one is commands, then documents, and events. What's interesting is that the same categorization works really well for most messaging systems. So, you know, which says to me that there is something fundamental about dividing your actions or messages into these 3 groups. So when dispatching a command, what we're doing, essentially, we're trying to sort of like invoke a method. Yes, dispatching a command is similar to invoking a method. Our intent is to tell some part of the system somewhere else to do something. Okay? And usually there is a single place, there is a single handler, you know, processing that command. And we often get a reply. We may expect a reply. Maybe it's a value, maybe it's an error. No, that's reasonable. And so those commands are. And I prefer to name my commands in this fashion, like a verb and, you know, a noun, like add a to do. Documents are different. As dispatching a document is essentially telling the system that this entity has been updated. Okay, that's it. We do not get a reply after dispatching a document. And there might be more than one place, more than one handler processing this document. So it's less procedural. Okay? And finally, I tend to name my documents using just plain nouns. Finally, an event, dispatching an event, basically tells the system that some change has occurred. And similar to documents, events are often handled by more than one place in our application, by more than one handler. And events do not provide the response. So it's like fire and forget kind of situation. And I name my events in this way. So something happened. Okay? So often, we need to use more than one action to implement an interaction, as I already mentioned. Here, for example, now when we know how we can categorize this action, we see that the first thing we are doing is we are dispatching the add to do command. That command is handled by an effects class. And then once we persist stuff on the backend, the effects class is going to dispatch the to do edit event, which is going to be handled by our reducer. Okay? So one interaction is both a command and an event. Okay? So those are the most obvious differences. Okay, we either expect reply or not, or we have one or many handlers. So I prefer using that naming convention I showed you because it goes a long way to show you what is what. So I recommend you to either adopt this convention or have your own. But we can also have application-specific conventions in addition to that one. For example, we can say that all documents must have an ID of the entity, or all events must have a timestamp, corresponding to when the event occurred. So in other words, we can impose our own schema on a certain action category. The last thing I want to talk about regarding actions is this idea of request reply. Because I showed you, or as I told you, then when we dispatch a command, we sometimes may expect a reply. The dispatch method, however, doesn't return anything. Okay? So how do we get that reply? Here, for example, I have a simple component that manages a to-do. It has a delete method. And say we want to confirm, when the user clicks on the delete button or whatever, that we want to confirm that this particular to-do should be deleted. So we need to ask the user. So we cannot do it locally. So we cannot just show the dialog here in this component, because this operation, the confirmation itself, may result, for example, in a URL change, or may result in other non-local effects. And when you're using NgRx, non-local effects have to be handled by effects classes. So we have to go through the same mechanism as I showed you. We have to dispatch an action and then somehow get a reply. Okay? So what is going to happen in reality here is that when we dispatch this action, we want to get that Boolean back. Yes? And in reality, what's going to happen is some effects class is going to pick it up, it's going to change the URL, it's going to display some other component, and at some point, it will get this result, that Boolean, is going to store it somewhere in the state. Because once again, when you use NgRx, any non-local state is stored in the stored state. Okay? So what we need to do now, after we dispatch it, we need to just query the state. So here I'm using select again to query the subset of the application state. And note I'm using the to-do ID to find the right response. Okay? By the way, IDs used in this particular fashion are called or often referred to as correlation IDs, because we use them to correlate our requests and our replies. Okay? And usually an entity ID, like a to-do ID, works really well for this kind of stuff. But when it doesn't, and sometimes it doesn't, we can always generate a synthetic one, like this. So here we generate an ID which is distinct from the to-do ID. Okay? So in addition to just supporting request replies, correlation ID, this ideal correlation ID, which is very, very useful, can be used for other coordination-related tasks. For example, if we want to make sure that a complex interaction that, for example, emits multiple actions or dispatches multiple actions is fully complete, we can assign the same correlation ID to all of those actions and then wait for all of them to complete. Okay? Okay, store. So we've learned about the 3 categories of actions we can dispatch. Now, the more interesting bit, okay, of the setup, the store. The store is where the bulk of the logic of your application is contained when you use NgRx to build your Angular applications. And if you watch talks on NgRx or Redux, what you'll find is that most developers tend to focus on reducers, okay, on the reducer bit of the store. I do not. And I think that reducers are actually very easy to understand. They're synchronous, simple functions, take the state, take an action, return a new state. There is nothing there to discuss. It's trivial. They're that easy, they're that simple to think about because the complexity of our application was moved. The reducer don't have the complex part of our application. It's somewhere else. And in the case of NgRx, that someone else is effects classes. Because effects classes in NgRx, they manage asynchronicity. They manage coordination. Okay? They coordinate multiple processes. They talk to the backend. That's the harder part. Okay? That's what we need to understand really well. And what's interesting here is that my experience of working on messaging systems on the backend applies really well to effects classes. Okay? So let's look at how we can apply some of it. In general, effects classes, what they do can be categorized into in three ways. First, they decide on how to process a particular action. Then they transform an action to some other form, which is easier to handle. And finally, they perform side effects. Okay? It is useful to have this distinction in mind, and it's even better if you can express in the code. Okay? So let's examine each of these blocks in detail. So a lot of what effects classes do is they decide how to process an action. Okay? And the simplest way to do it, the simplest decider, is the filtering decider. Okay? It is so common that NgRx comes with a special operator that implements it, called of_type. And it allows you to select, among all the actions in your application, sort of a subset of all the actions of a particular type, okay? Which is similar to this, essentially. We just filter it by type. The next one, the next common one, is a content-based decider. Here, essentially what we're doing is we're taking an add-to-do action, and we are mapping it to either append to do or insert to do, depending on the content of the payload. Okay, that's why it's called content-based decider. This makes sense when appending and inserting are actually fundamentally different or handled very differently. So this example is contrived. Obviously, here it may not make a lot of sense, but in large apps and real apps that evolve over time, these situations occur very often. Yes, and by doing so, we're introducing another law of indirection, which can be useful for a couple of reasons, because essentially it decouples what we dispatch, the action we dispatch, from what's handled elsewhere. Okay? The next decider, which is common, is the context-based decider. So it uses some information from the environment itself, from some injected entity, instead of the payload, to decide what a particular action should be mapped to. Okay? This is common as well when our application has distinct workflows which the component dispatching that action shouldn't know about. The component always dispatches one action, and then somewhere else here, the context-based decider will decide what that action should be mapped to and how it should be handled. Okay? And the next one is called a splitter. And what it does, it takes an action and maps it to an array of actions, so it splits an action. Okay? And it's similar to splitting one method into multiple methods. Okay? It allows us to test every single action independently, for example. Yes? Here, for example, we probably would like to test the add-to-do action without worrying about logging. The opposite of splitter is the aggregator. Okay? What it does, it takes an array of actions and it maps that array into a single action. Here, for example, we have two actions, to do, edit, and logged, which we assume are events dispatched by the actions we saw last time. And we sort of combine them, and we use the result of this combination to create a new action, add to do completed. Okay? The aggregator is a little bit more involved, so let me walk you through it line by line. So here we assume essentially that for every add to do action, we are going to receive, or we are going to have two actions back, to do, edit, and logged. Okay? Like this. So we are using the actions observable here to get the observable of length 1 for each of those actions, and not we're using the ID, the correlation ID here, to select the right action. And after that, we're using the zip operator to create a pair, and we can use this pair to create a new action out of the payloads of the action stored in that pair. Okay? It looks a little bit involved, a little bit verbose, the result of boilerplate there, but we can extract it by defining a very simple helper function. So we can always define a function that looks like this, and it will do the aggregation for us. Okay? So fundamentally, it's not more verbose than other deciders or other transformers or whatnot. It happens to be more verbose because RxJS doesn't come with one that does it for us. Anyway, so these are the most common deciders we tend to see when we build our applications with NgRx. The filtering decider uses the action type, essentially to process actions only of the type. The content-based decider uses the payload of an action to map one action to another one. The context-based decider uses the environment itself to map one action to another one. The splitter maps an action to an array of actions, and the aggregator does the opposite, takes an array of actions and creates one action out of it. Okay? So the next building block of our effects classes are action transformers. Okay? And the purpose of a transformer is to take an action and massage it or transform it into a different action. And it's very straightforward. The two most common ones, the first one is the content enricher. The content enricher takes an action, takes some information from elsewhere, and adds it to the action and emits a new one. Okay? This example is very basic because essentially we just have the current user available synchronously, already there injected. A more interesting example would be maybe fetching some information from the backend and adding that information to the payload. Okay? So the dispatcher of the action wouldn't know that we need to fetch this extra information, and the handler of the action wouldn't know either. So we have that intermediate step that will do it for us. Okay? The other one, which is very common, is the normalizer. Is when we take multiple actions that are somewhat similar, and we map them, we transform them into action of the same type. This is common if you have, for example, an upgrade project. If you are moving an AngularJS 1 application to an Angular application, And you just cannot dispatch the same action because of, you don't have the right data or whatever. So you dispatch similar actions. And then the normalizer will make sure to normalize all those actions to the same type so you can have a single handler working with them. Again, this example is obviously contrived, but hopefully the idea is clear. So these are some of the most common building blocks we use to implement the logic in our store. Yes, we have 5 common deciders, 2 common transformers. We have the reducer, which computes the new state, which takes the current state and creates a new one. And we have sign effects, which is essentially where we talk to the backend, store stuff somewhere, print stuff in the console and whatnot. The best part of about these building blocks is that they compose really well. Okay? So let's look at one example. So here we have a very complex interaction handled by NgRx. Essentially, what happens here is we are taking the observable of all actions happening in our application. We are filtering it, and that's how we usually start handling actions. Then we split it into 2 separate actions. Then for the top one, we are going to use a content-based decider to decide how to handle it. The bottom one is simpler. Then we execute all the needed side effects. Then we aggregate the results, and then we give this aggregation, this new action to the reducer, which will create a new state, which our component will receive. Okay? So this is very, very complex. In reality, what you usually see is stuff like this. Okay? So very, very simple. But the point here is that it is complex, but it's still composed of the same building blocks. We can still reason and talk about this example in a meaningful way because we have this language. And to make one thing clear, I'm not advocating you to split your effects classes into 5 different classes, because that would be nonsense or whatever. That's the last thing I would like you to do. So what I am advocating here is having a clear mental model of how your effects classes work, and having a language you can use to talk about them with your coworkers. Here, for example, we have a very, very complex action handling strategy. And don't worry about the code too much. The point being is that we're doing a lot here, and we're doing all of it in one place, in a single effects class. But even though we're doing all of it in one place, in one class, we can still annotate and see that our language, our pattern language, applies to this example as well. So we can see that in this effects class, we are starting with a filtering decider, then we're using the enricher, then the splitter, the content decider, then the splitter, and then that's how we create the first effect. And we can see, just by looking at it visually, that the first effect, the add to do effect, doesn't actually execute side effects. And the other 2 effects, the only thing they do is they execute side effects. Isn't it interesting? Because this property alone tells us that these effects, the first one and the other 2, should be tested and thought of in very different ways. Okay? And another important thing that it's all together, so we can have it in one place, and only when one of those pieces gets too complicated, we can extract it into a separate effects class or into a separate effect without affecting any of our clients and without affecting any other handler. Okay? All right. So let's review what we've learned. We've learned a few things. Okay? The first thing we've learned is that that's how NgRx works. And I think that the best way to present it graphically. Essentially, we have components dispatching actions, and then we have the store, which processes those actions, decides how to do it, transforms them, executes side effects, and uses the reducer to create new state snapshots consumed by the component. We've learned that even though NgRx is sort of very loose, it doesn't impose any categorization on your actions, it is useful to divide them into these 3 categories: commands, documents, and events. And we've learned that they differ in this way. Commands may expect a reply, and are almost always handled by a single handler. And we've learned that, for example, events and documents do not expect a reply. We cannot expect a reply when we dispatch an event, and there might be more than one handler. We've learned, or rather, we looked at the core building blocks of assembling our store. There are 5 common deciders, the 2 common transformers, have the reducers, and have the sign effects. And the best part of it is that we can compose them really well and implement even very, very complex interactions like this one using the same building blocks, the same primitives, and talk about them using the same language. And we also learned that I'm not advocating to having 15 different classes to implement a simple interaction. But too much boilerplate, too enterprise. Should be in one place if it works, but you can still use the language and you can still express it in the code, even though it's in a single class or in a single effect. The separation can still be clear. So the goal of this is not to make lots of classes, but rather to have meaningful conversations with each other. And then once we have complex pieces that get out of hand, we can extract those as needed without affecting any of the clients. Also, all of this is based on this book. And if you're using NgRx or if you're using Redux, let's say, this is the book to read. Pretty much every single complex thing about using NgRx or Redux is handled or written about in this book. So check it out. OK, cool. You can check out our site, check out our blog, and get one of those books. Thank you.